Bismillahirrahmanirrahim. Welcome back to my channel. This video we're going to explore another way I can use my RTL-SDR dongle and gnuradio to demodulate my FM signal. I think I made already a video on it, but this is a little bit different than the previous one. Just exploring different methodology that I can apply, different boxes that I have available in gnuradio to actually try to demodulate my signal, try to demodulate FM signal. And this is another way that I just recently explored. So let's just have a look at it and try to understand the flow graph. So before I do that, let's just do this. So definitely I gotta have an RTL-SDR dongle. It has to be connected to your laptop. So for that I'm using a SOPI RTL-SDR source. I have kept my sample rate to 2.048 or 2 megahertz. There's a reason for it because I wanted a channel rate to be 256K. That's why. And in this, the only thing that is being controlled by anything is the RF options. The RF options are being controlled by a frequency variable, which is being controlled by a GUI range slider, which I'll show you in a little bit. So the frequency is actually the frequency which is this. This is the frequency, generally 86 till 108 megahertz. This is the frequency range of your general FM radio broadcast, and the frequency, that's why. And the numbers are being multiplied by 1 megahertz, as you can see in this flow graph, in this box in RF options. So frequency time 1, so everything will be in megahertz. Now there are two streams that is going in this flow graph. The signals that my RTL-SDR dongle is receiving is in complex, so I gotta have complex to magnitude block. This complex to magnitude block will help me measure the magnitude or the power measurement that I can do. And integration, I'm doing integration just to do a power, because when you take a signal and when you integrate it over time, you will get power. That's why I'm using an integrate function, and it's just going into a number sync. So nothing fancy going on, no variables are being controlled here or anything like that. It's just, and number sync will give you power measurements. So this is one way. So whatever the signal that you're receiving, you're tuning your RTL-SDR dongle to, you will see the power measurements as part of your number sync graph. Now here comes the actual flow graph where the demodulation is taking place. You have your signal which is coming in and it's going into a low pass filter. I have kept a low pass filter rate to 8 because what will happen after this flow graph, after this box in your flow graph, your sample rate would be 8 times of that. So my sample rate is about 2 mega now. So having a decimation factor 8 would give me a sample rate of 256K. This is what I wanted it in my future boxes after this box. After this. Alright, then you have a cutoff frequency. Cutoff frequency is being set by your frequency bandwidth divided by 2. So this is that variable which is controlling this. So the default frequency is about 200 kilo, and then starting from 110 kilo and all going all the way up to 250 kilo, and in an increment of 10 kilo. So this is setting up my frequency bandwidth. Basically what it's doing is actually cleaning up my signal before it goes into a demodulator. So this low pass filter, the job of this low pass filter is just to clean up my signal. Yeah, whatever the signal that I'm getting, I'm going to clean that up and I'm going to give it to my frequency FM demodulator block. Now if you were to go ahead and look at your FM demodulator block, now your channel rate is sample rate times 8. Because if you look at your decimation rate, this is about 8 times. So you're almost getting what? 256, because you gotta keep the same sample rate throughout your flow graph. If some sample rate is going down, you gotta have another block that should actually have a same sample rate. And sample rate basically mean how quickly the samples are coming in. So that's the reason. So if you divide 2.048 mega, 2.048 divided by 8, if you do that, you will get 256 kilo samples. That's why I have it in terms of channel rate here. You have an audio decimation too. Now after this you can clearly see you have a decimation block. Decimation means you need to, the signal is further going down, decimating. So right now you have sample rate of about 200, channel rate of about 256 kilosamples. You're going to further divide in further boxes in this flow graph. We'll have a look at it in a little bit, what I mean to say, and you will see that. All right, deviation is standard deviation. I'm keeping it as is because 75 kilohertz is a default deviation rate, and then this is an audio pass, which is 65,000, 67,000. All the values are exactly the same. So let me close this. Now, if you go ahead, and the output of this is going into a frequency sync. So we are just looking at the frequency demodulated output and frequency sync after cleaning up my signal. Now the signal is also going into my low pass filter. Now if you were to look at it, look at this, quickly look at this. You have sample rate and you have a decimation of 256. So 256k divided by 2 would give you 128k. So that's why I have to have it 128k of sample. Now there is this also, and after this you also see another decimation factor, that after that the sample rate will be coming out at a different sample rate. So if you were to look at it, so 256k divided by 2 is 128k. That's why I have set this to 128k. Further, I have divided this more. Let's just look at it in a little bit. What is the cutoff frequency that I have set? 15 kilohertz. Why? Because this particular low pass filter here is actually setting up the frequency so you can hear it, because generally the hearing audible frequency that we can generally hear, a human can hear, is from 20 hertz to 20 kilohertz, and 15 kilohertz is basically the cap for most of the people. So 15 kilohertz. So now 256 divided by 2, having a decimation factor, is giving me 128k. That's why I have to keep my sample rate to be 128k. Now further, this has a further decimation of 4. So 128 divided by 4 would give you what? 32 kilohertz. Just to keep the sample rate same along the flow graph, that's why I have chosen my audio sinks to be 32 kilohertz. Now this multiply constant block is basically whatever the output is coming out, you're just going to simply multiply it. So sort of this thing is working as an audio gain, which is being controlled by here. So this is that audio gain which is being controlled, and I have chosen this to be a knob. So that's why it's being, you will see a knob. And 32 kilohertz is the sample rate. So every single block in this flow graph is following a particular sample rate. And so this thing started off with 2 mega samples, decimating it down to 256, decimating it down to 2. You have to tell the next block what would be the sample rate. As this one is 128, 128k divided by 4 would give me 32. Will it make a difference if I choose this to be 48 kilohertz? Because you can choose this to be 48 kilohertz. I don't think so. I didn't see any difference. So you can keep it to be 32 or 48 or 44.1. It doesn't matter. It's not making a huge difference. So let me run this flow graph now. So this is the complete picture of your flow graph, of FM flow graph. And we're going to receive live signal, and we're going to clean it up. This flow graph will clean this signal up. We'll also make it cleared so you can hear it. And let's just do it. So you should have your RTL-SDR dongle connected, and you can see what will happen when I press the play button here. So all the information will be here. As you can clearly hear, you can still hear it. And right now, the default frequency is about 93.3 megahertz. You can control your gain, the gain limit, the bandwidth limit. The gain limit here for RTL-SDR dongle is about 29 dB. But I was playing around with this, nothing is making a difference. So the signal, the power measurement is taking place. So you're getting about one power. That's what you're getting, and this is the volume. So this is basically the volume control. And this is that post filter right here. You can see this. Then the output of this is after this. This is the filter. This is the output you're getting, and this is that. This is that sync output that you're seeing right now. So these are the two outputs. So you're getting this output. All right, this is the output, and this is this output. You can tune on to different frequencies you want. So this is the default frequency that I have set, which is 93.3. Let me just turn on the volume so you can see it, what's going on. This is probably the best you can get, because this GUI is actually the representation of an actual signal that you're getting it, which is right here. This is that representation of that signal. Then you have second one, which is the post filter, and then after this you're getting this output. So you can tune on to different frequency. Here we go. So you can hear this, and let's tune on to another frequency. And in this way, so you got the gist of it, what I'm trying to say. In this way, you can actually look at your measurement, power measurement as well. You can tune around, you can play around with your frequency, you can play with your volume button and things like that. So I hope you find this video or this tutorial helpful. If you have any questions, leave it in the comment section, and don't forget to like and subscribe to my channel, and thanks for watching.